Okay, so now we're going to extend this idea. We're not just going to write fractions with numbers on the bottom for exponents. We're going to put fractions numbers on the top and the bottom. Okay, so for example, a to the power of m over n. Okay. Now this basically works the same way. Our base is the letter a. There's a root sign because there's a fraction. The number on the bottom of the fraction goes in front of the root sign and the little index number. And the letter m, we have two options. We can do option number one, which is my preference. Okay, put everything on the inside, and the m would go on the outside. Or so option number two is we write the index number, but we put the top exponent on the base. Okay, so for example, just to show you how this is going to work, if I had 25 to the 3 halves, okay, I could write this as 25 as my base. My index number is 2, and a 3 on the outside. My preference is this one. I like to do this because I take my nth root first and then my exponent. But I also could do, if I don't like that version, I can do 25 to the power of 3 and then do the nth root, the second root of that. Okay. Now, as I said, I'm going to use the top one most of the time, this version. I think it's easier to make smaller numbers as opposed to bigger numbers. But there's nothing wrong with doing it the other way either. Okay, so we're going to, again, write these in radical form, and then we're going to evaluate them. So, 32 to the 3/5. My base is 32, so I can take the root of that. Okay, my nth root is 5, the 5th root. And I want to do all of that to the power of 3. So first thing I'm going to do is my calculator. The 5th root of 32 is 2. All of this becomes 2. But we still have that exponent of 3 on the outside. So put a power of 3 out there. And 2 to the 3 is 8. So it gets smaller and then gets a little bit bigger again. Okay, if we try the next one, negative 27. Now notice the negative sign. Okay, it's not included with the base. So my answer is going to be the negative of whatever. Our base of 27. My nth root is 3. My exponent is 4. My negative sign, what's the cube root of 27? Well, that's 3. My exponent is 4. What is 3 to the power of 4? It's 81, and it happens to be negative. Okay. Try the next one. 16 to the negative 3 halves. Oh, I see a negative exponent. What do we do with those? We flip them over. My exponent becomes a positive. I end up on the bottom. Then we do everything all over again, right? 1 over. My base is 16. The nth root is a 2. Your choice. You don't have to put the 2, remember. My exponent is 3. What is the square root of 16? Well, that number is 4. But I still need that 3 out there. I haven't dealt with that yet. And 4 to the power of 3 is 1 over 64. Now, one of the common mistakes is people start losing this 1 right here. Make sure you carry it all the way down, right? Because when you flipped it over at the beginning, it became a fraction. Okay, let's try some more. I see a negative 8 in brackets. So my whole base is negative 8. It's a fractional exponent. So the 3 in the nth root part, the 2 on the outside part, cube root of negative 8. That's going to be negative 2. Okay, power of 2 on the outside, negative 2 squared, so 2 negatives makes a positive, and it's 4. Okay, be careful using your calculator. You're putting things in the way they're supposed to look, right? With brackets or including that negative sign. Don't lose those signs. They're kind of important. Okay, letter E. I got a fraction. Oh, a fraction to a negative exponent. We said yesterday when you get fractions and negative exponents, you can flip the whole fraction. And your exponent becomes a positive. What does that 5 halves have to be applied to? Well, it's got to be applied to the 4 and the 9. So if we think about it, this really means 4 to the 5 halves over 9 to the 5 halves. And we're going to have to evaluate each part of this separately. So if I write them as radicals, 4, I can put the 2 in if I want to, a 5 on the outside. On the bottom of the fraction, 9. Okay, I don't write the 2 this time. I didn't have to. Remember I said there was an option, right? You don't have to. It's assumed that there's a little 2 right there. You don't have to put it in there, though. The square root of 4, what is that? Square root of 4 is 2. I've got the 5 on the outside. Square root of 9 is 3. 5 on the outside. 2 to the 5 makes 32. And 3 to the 5 makes 243. Okay. And I'd really like you to try and use the radicals, because number one, it asked us to, and show your steps as you work your way through this, so if we come across any problems, you can figure out where that happened. Okay, I know it's tempting to just throw this right in your calculator from the beginning, but then you get ugly, messy decimals, and we don't really want decimals, we want fractions. Okay, but there's where we get that answer from, 32 over 243. Okay, we're going to work backwards now. So I've got some radicals. Can you put them back into exponential form for me? Okay, so I see a 34 and a root sign. My base is 34. It's a root sign, which means it's a fraction. The number in the front goes on the bottom. There's no number there, so it's a 2. There's nothing else, so it's got to be a 1. Try the next one. The base is an A. There's a root sign, which means it's a fraction. Number on the outside goes on the bottom. Number on the inside goes on the top. So 8 to the 2/3. All right, look at the next one. What do I see here? Okay, my base is an A. I see a fraction. That means my exponent had to be a negative to make fractions, right? I also see there's a root sign, which means I need a fraction in my exponent. Number on the outside goes on the bottom. Number on the inside goes on the top. There is no number, so it's a 1. And there's my answer, A to the negative 1/3. Let's try the next one. X to the 6. All right, my base is X. I see a root sign, needs a fraction. There's no number, so I know it's a 2. The number on the top goes on top. And if I wanted to, I could actually simplify this, right? 6 over 2 is the same thing as saying x cubed. You know, if I go back to say, it doesn't say simplify, it just says right equivalent. But those are two different versions of the same thing. Okay, it's looking slightly more complicated now. Let's give the next one a try. I got x as my base. I've got a fraction. So I'm thinking about this one right here, okay, the inside one. That means I need a 2, because there's no number in front. And what's on the top? Well, the top would be a 6. Now, if I stop right there, stop for a second, I haven't dealt with this piece yet, right? I've only dealt with the inside part. So I've got to do this again. Now, I said a second ago, it might make sense to make this into a 3, right? I think that would make sense. 6 over 2 is 3. Okay, so what can I do with this next? Well, my base is x. I see a root sign, so it's a fraction. The 4 is on the bottom. What's on the top? Got to be a 3. Okay, so we've taken 2 roots. I have to do something twice. Let's try f. Okay, working on the inside out. My base is 8x. Now that 7 is not on the 8 and the x, it's only on the x. So this is a weird case. I need to put the 7 there to remind myself it's only on the x. What's going to be on the outside? Well, it's a fraction. The bottom is a 3. And I'm going to have to put a 1 up here because, and not the 7, because the 7 wasn't working on both parts. It wasn't working on the 8 and the x. It was only on the x. Now, something I could also do if I want to work on the next root sign, I can put more brackets around it. That's another root sign. It's another fraction. There's a 2 here, so I could put a 2 here and a 1 here. And so every time I have an extra set of root signs, I can add more fractions on the outsides of my brackets. If I want to simplify this, 8x7 I can't do anything with, because I can't do anything with the 8 and the x7. They're two separate parts. The 1/3 and the 1/2, well, based on yesterday, that's a power to a power, right? And we're supposed to multiply when I do powers of powers. And if you remember anything about fractions, to multiply fractions, you go straight across. So 1 times 1 is 1, and 3 times 2 is 6. And there's your simplest answer that you can make. Now, as I said, this is a weird one, because the base was made up of more than one part. If that's true, my base has to keep going all the way down, one part, one part, one part, as opposed to the ones we did previously, where I only had a single part of my base, and I could keep simplifying. Okay? Okay, that's the end for today. Give the quiz a try if you can, and make sure you tried your homework.